So hello again and welcome to Cluster 7 Qualification National Certificate in Business Administration Services Level 3. In this cluster, we work with number bases and measurement units. We describe, apply, analyze and calculate shape and motion in 2 and 3 dimensions. We plan and conduct basic research. We investigate life and work-related problems using data and probability. There are 2 types of number systems. Decimal number system, which is made up of 10 digits out of a base of 10. The binary number system is only made up of 2 digits and it's a base of 2. This system is used in computers. Every number you come across in life is made of 10 numbers. For computers to be able to communicate decimal numbers back to us so that we can see them as decimals, we need to be able to convert between binary and decimal numbers. You are going to learn how to perform addition and subtraction with binary numbers. In general, the relationship between a digit, its position, and the base of the number system is expressed by the following formula: the digit multiplied by the base position number. So as the numbers move up to the left, the alternative binary digit is used, thus creating the 0 to 9 in binary digits. A 0 is a 0 in binary, a 1 in binary. Now we only have one more digit, which is the 0. Therefore, 2 is made up of 1 and 0. As we move down the list, a 3 then, the 0 is then replaced by the 1. And as we go to 4, the 1 is then replaced by a 0 and an additional 0 added at the end. And so they carry on until we get to the 9th digit. For a simple method to be able to calculate or convert decimal numbers to binary, we'll use the following table. From the left, we start with the number base 1, and then 1 added to itself equals to 2, 2 plus 2 equals 4, 4 plus 4 equals 8, and so we carry on with our table. If we took the binary number 1000, and we placed it in the table from right to left, so we've got 0 under 1, under 2 we've got 0, under 4 we've also got 0, and under 8 we have 1. Now to convert the number, we take the values where there's a true answer. So in other words, we have a 1 which equals true and a 0 which is a false. So if we have 1 under the 8, that means that 1000 is 8 in decimal system. Let's take a look at the next example. We have the binary number 111. So if we have the binary number 111, and notice that I'm not saying 111 because it's not 111, it is 111 in binary number system. So if we take those numbers from left to right, under 1 we have 1, under 2 we have 1, and under 4 we have another 1. So everywhere where there's a true value, you'll add the decimal numbers together to get the binary number. So let's take a look. Under 4 we have 1, so 4 plus, then under 2 we have 1, so that's plus 2, and under 1 we have a 1, which is another 1. So we have 4 plus 2 plus 1, and that equals to 7. So that gives us the decimal number 7. The next example, I'm sure you can work that one out for yourself. We have a true value 1 under the 2. So that means that is showing me that that's the number 2 in the decimal number system. Remember that always when you want to do conversions. You'll need to use this method if you want to subtract as well. You convert the number back to a decimal, do the subtraction, and then convert those numbers back to a binary. So this will be your base for conversions. Remember those, it's not the only way. There is other ways. If you find another way that's simpler for you to understand, you're welcome to use it. Now, just as with any other mathematical system or numbering system, we have rules. So because binary numbers only consist of 2 digits, there are some rules that we need to calculate. So we've got 0 plus 0 will always equal 0. That we need to remember. A 0 plus a 1 is equal to 1. A 1 plus 0 is equal to 1. And the only time in your lifetime where you'll be able to say that a 1 plus a 1 is equal to 10, which we're not allowed to say. It's a 1, 0, remember? Okay, but this is the only time in your life that you'll be able to say that a 1 plus a 1 will equal a 1, 0. Let's take a look at some examples. If we needed to calculate 1, 1 plus 1, 1, the calculation will look as follows. The 1 plus 1, remember our rule, equals to 1, 0. So we take a 0 down and we carry 1. Then we have 1 plus 1 again, which is once again 1, 0. Now we have an additional 1, so that becomes 1, 0 again, which means we bring a 1 down. And always generally, 1 plus a 1 plus a 1 will always equal a 1. So we bring that 1 down, and then we still have 1 left, which will be the 1. So 1, 1, 0 is the answer to adding 1, 1 and 1, 1 together. Then if we look at another example, if we had to add 1, 0 plus 1, 1, we have 1, 0, 1, 1. So 0 plus 1 is a 1. So we bring 1 down, and a 1 plus a 1 is a 1, 0. So it's 1, 0. So our answer then is effectively 1, 0, 1. Now I want you to go back to the table, and I want you to take those two numbers and then put them into the table and convert them into a decimal, just to make sure that you have a good understanding. Often the measurements that scientists make involve values that are either very large or very small. To write numbers with many digits would be time-consuming, so a hand system was developed, or a shorthand system rather, was developed, which is called scientific or exponential notation. By representing values with scientific notation, it is easier to write those values and use them in mathematical calculations. The first part of the equation B is called the base, which is a number that is less than 10 and greater than or equal to 1. The E is the exponent, which is the number and tells you how many spaces to move the decimal point. When the value of the exponent is positive, you move the decimal point to the right for the number of spaces indicated by the exponent. A positive exponent is used to indicate a large number. When the exponent is negative, you move the decimal to the left, resulting in a number less than 0. So to convert from scientific notation to an ordinary number, just move the decimal point the same number of spaces as the power. When the power of 10 is positive, move the decimal point to the right for positive direction on the number line and the same number of spaces as the power. Prefixes in measurements are the letters placed before a measurement. Metrics are standards of measurement. Therefore, metric prefixes are letters and or words placed before a measurement. Now, you've probably heard of some of these. If we look at meters, we have kilometers, which is 1,000 times of a meter. Then we get centimeters, which is 1/100th of a meter. Let's take a look at some other measurement units. There are two different types of measurement systems: imperial units and SI. In South Africa, we use the metric system, imperial. In the UK and the US, they use the SI system. Imperial system includes things like kilograms, kilometers, centimeters, Celsius. In the SI system, we talk about pounds, miles, inches, and Fahrenheit. So let's take a look at some examples of conversions between the imperial system and the SI system. Remember, grams is the measure of weight, meters the measure for distance, and liters for liquids. These are only some examples on the conversion measurements. There are many more. Consult the internet and or your learner guide for a full list of measurements and conversions. So let's take a look at pounds. 3 pounds, if we took 3 pounds as an example, we need to multiply that by 0.45, and that will give me 1.35 kilograms. For inches, if I took the same amount of inches, I said 3 inches, we multiply that by 2.54, and that will give me 7.62 centimeters. For pounds, we multiply by 0.57. Celsius and Fahrenheit is a different story. There we use the formulas as shown. For Celsius, if we want to calculate, if we want to convert from Celsius to Fahrenheit, we take the degree Celsius, we multiply it by 1.8, and we add 32, and that will give us the Fahrenheit value. If you look at converting from Fahrenheit to Celsius, to find Celsius, we take Fahrenheit minus 32 and we divide it by 1.8. Note that these values don't differ. You've got to go and consult the table to find out what the other values are for the other metric systems. Now in the decimal number system, we get two different types of numbers. There's two types of numbers, rational and irrational. Rational numbers are called integers, which is any whole number. Irrational numbers are those numbers that can't be expressed as a fraction, but can be expressed as a decimal. Now, if we take a look at the examples, you'll see they're rationals. Rational numbers is not just whole numbers, it can be decimal numbers as well, just as long as you can express them as a fraction. Irrational numbers, on the other hand, if we take a look at those examples, 0.121122, generally when we have numbers that are repeating, they're irrational numbers. And then we get the ever popular pi. Pi is the symbol that's used for the ratio of the circumference of a circle to its diameter. So that's the value that we use when we want to calculate the circumference of a circle. Now, irrational numbers have endless non-repeating digits to the right of the decimal point. Irrational numbers are not often used in daily life, and they don't exist on the number line. Rational numbers are any number that can be written as a ratio, meaning as a fraction, a number over another number. The top number is the numerator and the bottom number the denominator, and this equals to the ratio. To add rational numbers, or fractions as we call them, we need to find the common denominator first. Now in our example, 5 divided by 8 plus 4 divided by 5, we need to find a value that 8 and 5 can go into. Now our common denominator is 40 because we established that, and that's the denominator that both can equally be divided by. So 8 being the denominator goes into 45 times, and 5 times by the numerator, which is 5. So we multiply 5 by 5, which gives us 25. The 5 denominator goes into 5 8 times. Then we multiply the 4 numerator by 8, which gives us 32. Then we add the numerators of the fraction, which is 25 plus 32, and that is 57. And then we divide 57 by 40. Now we can already see that 40 can go into 57 once, and it leaves a value of 17. So it's 117 over 40. To subtract the fractions, the same will apply, only that we subtract the numerators instead of adding them. So our result will then be a minus 7 divided by 40. Rounding numbers is the process of rounding a decimal number to the closest decimal value, to the nearest tenth. Numbers can either be rounded up or down. Let's say we wanted to round to the 1 decimal of the example 1.578. We start looking from the left. If the value is greater than 5, in this case it is 8. Then we increase the next number to the left by 1, making our 7, then an 8. This also then increases the 5 to a 6, so our rounded up number is then 1.6. If we wanted 2 decimals, it would be 1.58. If we're rounding down, the same process will apply. The only difference is we'll use the lesser value rather than the increased value. So our value then will be 1.5, and if we had 2 decimals, it would be 1.57. Rounding errors is the difference between the true value and the nearest rounded value. This may cause measurements to be inaccurate if not rounded to the best true value. Now, this is one of the things we need to be aware of in business, typically not just with measurements, but with values as well. Because as we can see from the example table, if we had the value 1.78899, if we rounded it up, the value would be 1.79. But every time we round up or down, the value changes. And if you look at the end values, you can see in the first example, we've got 259.11. And the second example, we've got 259.11, which is coincidental. But over a range of values, this may change. It may even change to 2.60. And then we have a problem, because when we're working with millions of rands or millions of measurements or longer lengths, when we round up or down, that could make a very big difference. Or let's say you have a specific space in your home where you can only fit in something that is 40 centimeters long, and you buy something for 40.1 centimeters. If you say 40.1, you may find yourself with a situation where the object can actually not fit within that specific space. Or let's say you've measured a specific space in your home, and it now measures 40.99, and you go and you round it up to 41, and then you go and buy a piece of material that costs you maybe 10 or 20 bucks more for that extra 1 centimeter. That could have cost you money. Now, it seems very small because we're talking about small amounts, but as I mentioned, when you get to millions, it does become a huge problem. And that's a wrap for Cluster 7, Topic 1. Let's take a look at our main ideas. There's two types of number systems, decimal and binary. Decimal number systems have a base of 10, while binary only have a base of 2 numbers. Remember to apply calculating rules when calculating binary numbers. In South Africa, we use the Imperial Metric Measurement System. Most other countries use the SI system. Rational numbers are whole numbers, while irrational numbers are all numbers that can't be expressed as a whole. It is important to round according to the rule and make sure when true values are needed and when it is okay to use a rounded value.